Hello, we are Team 3, the Shard. Last week, we talked about top-down construction, foundation, pile left. This building is built by top-down construction, that is built upper and lower part at the same time. It can save much time. The left end piles supporting the left served as the foundation of the shard building. Pile left foundation is a type of pile inserted into an existing left foundation. The pile left foundation can withstand more load with friction with the ground than early left foundation. It can also transfer load to hard strata beneath the soil. It can also withstand shear loads such as wind and earthquakes better through piles. And there is a part underneath the shard's ground layer, divided east and west. The ground part requires longer east piles than west. We explained according to the procedure in which the buildings were built. So far, we explained history, background, foundation, and constructional constraints of building, and so on. Therefore, today, I'm going to talk about the core built on the center axis and the steel frame from 1st to 39 floors. First, we will explain about the shard's core system. Last week, we explained about why the stable foundation is needed to the building. The stable foundation is needed to bear up the load the building without subsidence or incline. But there also needs media to deliver load like gravity and wind load to foundation. That is why the core system is important to the shard building. To take all kinds of load evenly, the core structure is located at the center of the building. The core structure contains elevators, stairs, and toilet. By concentrating the piping equipment and electric installation, the length of the facility is shortened, which means the installation expense is decreased and the maintenance of the system becomes simple. Previously, we talked that the plunge column is launching structure of top-down construction. And we explained the plunge column becomes a frame of the core structure. Core structure is constructed above the plunge column to deliver loads directly to the piles of the building. To construct the core structure, construction team used slipform method. By understanding of the conventional formwork, we can realize easily why they use slipform method instead of conventional formwork. Conventional formwork has a repetition pattern of formwork installation, concrete pulling, and formwork removal. By watching the conventional formwork video, I will explain again briefly. Install the formwork. After installing the formwork, pour the concrete. Remove the formwork. Reinstall the formwork upstairs and repeat the whole process. Slipform has a pattern of only two actions after formwork installation: concrete pulling and formwork movement. Instead of formwork reinstallation, slipform method just lift up formwork. These are the devices used in the slipform work. Yoke and lift jack, which is used to slipform method, make a movement of formwork. By watching the slipform method video, I will explain again briefly. Install formwork and lift jack. And pour the concrete. After concrete is hardened, lift up the jack, which consists formwork, and repeat these things. This saved more time than before, maintained the workspace in a constant form, and saved money for installation and reinstallation. The core built on the plunge pile at the second basement. Top-down construction. According to the top-down construction method, the excavation of the third basement floors and the core slipform were started simultaneously. And with a certain amount of core up, look at the left. You can only see that it bears the shard load. And put core wall up here. It allows for more direct delivery of load. Thus, the core was built up to a height of 235 meters, and the core became thinner depending on the shard's appearance. You may think that thinner cores are difficult to withstand the load, but the shard is shaped like a triangle. This shape receives relatively less wind than other rectangular buildings. Therefore, relatively little wind pressure applies to the buildings. Perimeter columns are installed according to their appearance. These columns are responsible for resisting small wind pressure and loads. Also, it has an outrigger truss system with perimeter columns connected to the core through head trusses on the 68th floor. It makes it more stable. Next, I will explain steel frame. The Shard is the tallest building in Europe. Height of the building is 310 meters, 54,000 cubic meters of concrete, and 12,500 tons of steel was used. The Shard has three different structures. First to 30 floors are steel frame. 41 to 69 floors are post-tension concrete, and spire is steel. We will talk about steel floor in this presentation. First, why the building is separated to three different materials. Because each floor needed different things. For example, office floors needed large spaces and residence floors needed less movement and high fire resistance. Engineers solved the need of each floor by using different materials. We will talk about steel structure for this presentation. So, what is the advantage of steel structure compared to reinforced concrete in office floor? To explain this, introduce the characteristic of steel structure. Steel structure has both advantages and disadvantages. The advantage is that steel has excellent stiffness and toughness. This is stress-strain graph of steel. Steel has high modulus of elasticity. It means stiffness is good, and toughness is area of the graph. Toughness is proportional to area of stress-strain graph. And steel has uniform quality, unlike concrete, because steel is made in factory. This is very good at analysis and design of load compared to concrete. And steel has high specific strength. Strength divided by density, much bigger than that of concrete. But steel also has disadvantages. The most important is corrosion. Steel is good reductant because of the redox of steel. Steel becomes oxidized. To block this reaction, many methods is developed, such as painting and galvanizing. And steel is vulnerable to fire. It is very important to skyscraper. For example, World Trade Center. World Trade Center was collapsed because of deformation of steel structure. Steel temperature became higher and distribution of heat was not even. Therefore, the high temp steel was deformed first, and unbalance occurred. After 911, steel structure was almost not used in skyscraper because of perception of people. So, why engineers of the shard use steel structure? Because office floors needed large spaces and steel has high specific strength than concrete. So, engineers chose steel at low floors. Engineers expanded the span of floor to 6 meters by using composite steel frame. The height of each floor is 3,650 mm and thickness of slab is 850 mm. And this is structure of steel frame slab. Slabs consist of lightweight concrete on reentrant metal deck, giving a 130 mm total depth, working compositely with fabricated steel beams. This is a video of stacking of the core and to the 14th floor. The table below shows the progress of the building according to the date, and the table above shows what is being built. Our team member is like this, and resources. Thank you for listening. We are Team 3, The Shard.